When you walk through a forest, what do you see? Towering trees, vibrant plants, the rustle of leaves. But what about the silent observers, the creatures that seem to appear from nowhere? The ones that are neither plant nor animal, yet they're essential to everything around them. Today, we're going to step into the hidden kingdom of the mushroom. Forget what you think you know. Because what you see above ground is just a fleeting moment in a story that's been playing out for billions of years. A story that holds the key to our past, our present, and our future. A hidden world of communication and life that is far more complex than we can imagine. A world that exists just beneath our feet. The truth is, the mushroom you see is not the organism itself. It's simply the fruit, the reproductive part of something far, far greater. The true body of a fungus is a sprawling, intricate network called mycelium. Think of it as nature's internet, or perhaps more accurately, its sensory organ. A vast, silent, subterranean web of threads that can stretch for miles and even cover entire continents. This network is the true living being, constantly searching, connecting, and communicating in the dark. It is this living web that allows life as we know it to exist. Mycelium acts like a massive neural network, transmitting nutrients and information across the forest floor. It can detect new food sources, identify threats, and send chemical signals and even electrical impulses to other parts of the network to prioritize growth in that direction or mount a defense. It's a silent, invisible intelligence, a biological internet that has been operating beneath our feet for millennia, holding the entire ecosystem together in a state of quiet, constant communication. So, how does a mushroom come to be? It all starts with something you can't even see: a spore. These microscopic particles are essentially the seeds of a fungus, but they are far more resilient. They are carried by the wind, water, or even insects. The spores are so light and numerous that a single mushroom can release billions of them in a single day, ensuring that at least a few will find a place to grow. They can lie dormant for years, waiting for the perfect conditions of moisture and temperature. When a spore lands in a suitable place, a moist log, a patch of fertile soil, it germinates, sending out a single thread of mycelium. This thread, a hypha, branches out, intertwining with others. When two compatible hyphae meet, they fuse, creating a genetically unique new network. This new mycelial web then grows, creating an exponentially growing network that consumes and transforms its environment. When conditions are just right, the perfect temperature, humidity, and nutrient availability, the mycelium decides it's time to reproduce. It gathers its energy, and from its hidden web, a tiny, compact mass known as a button emerges. This button grows with incredible speed, often doubling in size overnight, fueled by an internal influx of water, until it unfurls into the beautiful and complex structure we recognize as a mushroom. Its sole, magnificent purpose? To release more spores and continue the cycle. Mushrooms aren't just a part of the ecosystem, they are the ecosystem's architects. Their primary job is decomposition. Without them, the forest floor would be buried under dead trees, leaves, and animal waste. Mycelium works as a biological recycling factory, secreting powerful enzymes that break down complex organic matter, even the tough cellulose and lignin found in wood. These are compounds that few other organisms can break down, making fungi the planet's essential cleanup crew. This process transforms dead biomass back into simple nutrients that plants can use. They are the great recyclers of the planet, ensuring that energy and resources are never lost. But their role goes even deeper. Fungi have a unique and profound relationship with trees and plants. Their mycelium can form a symbiotic bond with plant roots in what is called a mycorrhizal relationship. The fungus acts like an extension of the plant's root system, delivering water and vital nutrients like phosphorus and nitrogen that the plant's roots couldn't reach on their own. In return, the plant provides the fungus with sugars produced through photosynthesis. It's a perfect partnership, a give and take that allows both to thrive. This relationship is so foundational that up to 90% of all plants have a mycorrhizal partnership with a fungus, making this underground trade network the true engine of our forests. It's also through this network that plants can communicate, sending warning signals to one another when faced with a pest or disease. From the earliest days of humanity, our story has been intertwined with fungi. They've been used for millennia for their incredible properties. They've been a source of food, a foundational part of traditional medicine, and even a catalyst for spiritual practices across different cultures. The very concept of fermentation, for example, is a partnership with fungi. The yeasts that leaven our bread and ferment our beer are all fungi, creatures we have co-opted to create staples of our civilization. The discovery of penicillin, one of the most important medical breakthroughs in history, came from a fungus. It was a happy accident in Alexander Fleming's lab, where a mold, a type of fungus, grew on a petri dish and killed the surrounding bacteria. That simple observation changed medicine forever, ushering in the age of antibiotics. This is just one of many medical innovations derived from fungi. Traditional Chinese medicine has used fungi for centuries, and scientists are now exploring their use in developing treatments for everything from cholesterol to cancer. We are, and have always been, inextricably linked to this kingdom. And the journey is far from over. Today, scientists and innovators are looking at fungi to solve some of our biggest problems. Imagine buildings that are grown instead of built, with bricks made from compressed mycelium. These bricks are lightweight, fire-resistant, and can be grown in any shape, offering a sustainable alternative to traditional construction. They can also be used for biodegradable packaging and even soundproofing. Or imagine oil spills cleaned up not by harsh chemicals, but by fungi that can break down complex hydrocarbons and other pollutants in a process called mycoremediation. They can even be used to neutralize pesticides and heavy metals from contaminated soil. This is the world of mycomaterials and mycoremediation. From sustainable packaging to leather alternatives, to new ways of cleaning our environment and even creating sustainable meat alternatives, the humble mushroom is poised to be a major player in creating a more sustainable future. So the next time you see a mushroom, don't just see a strange little cap on the forest floor. See the tip of a magnificent iceberg, the single note in a symphony that has been playing for eons. It's a reminder that beneath the surface, there's a world more complex and connected than we can ever imagine. They are the quiet shapers of our world, the great communicators and recyclers, and perhaps the solution to some of our most pressing problems. If you found this fascinating, please give this video a like and subscribe for more deep dives into the unseen world around us. Let me know in the comments which part of the mushroom's world you found most surprising.